It's my pleasure to extend a cheerful welcome to you all to this free online summer course on 4D printing and unmanned aerial vehicles. Welcome the challenges, look for the opportunities in every situation to learn and grow in wisdom. I now extend a warm welcome to our resource person for this evening, Mr. Jawahar, on behalf of our respected college chairman, Sri D. Duraisamy, Vice Chairman, Sri D. Parandaman, Secretary, Sri D. Dasarathan, Joint Secretary, Sri S. Gopinath, Correspondent, Sri S. Amarnath, Director, Sri D. Sabarinath, our beloved Principal, Dr. S. Ramachandran, Head of all UG and PG departments, professors, and faculty members, and students of our institution. Mr. Jawahar is a junior SAP executive in Sri Agarwal ISPAT Chennai Private Limited. His technical proficiencies include AutoCAD, CATIA, NXCAD, and NXCAM. Thank you, Mr. Jawahar, for joining with us today. Before we begin with this event, let me share a brief introduction of our institution. Dharmanoid Educational and Charitable Trust established SA Engineering College in the year 1998 to 1999. We are a NAC A grade and ISO 9001-2015 certified institutions located at Tirverkadu. All our departments are NBA accredited. We are working autonomous for 2019 for a span of 10 years. We have 24 years of excellence with 9 UG programs which include BECE, EEE, CSE, Civil, Mechanical, and BTech IT, Artificial Intelligence and Data Science, Computer Science and Business Systems, along with 6 PG programs which are ME CAD-CAM, CSE, Communication System and Embedded System Technologies, MBA and MCA. We also support various doctorate programs in CSE, ECE, EEE, Mathematics and Mechanical Engineering. SA Engineering College stands out in the crowd for its Anna University recognized research center with 27 funded projects where students get chance to work on these projects. We provide highly comprehensive placements of about 90% each and every year. We have achieved 90% of placements even during this pandemic in the year 2020 to 2021. Our top recruiters include Avasoft, Rapidata, Emphasis, Infosys, Capgemini, CTS, TCS, Zoho, L&T. We have introduced the latest courses on artificial intelligence and data science, CSE and business systems. We have state-of-art infrastructure, including Internet of Things Lab, Product Design and Development Lab to conduct research projects. SA Engineering College maintain high standard of education by providing a wide array of world-class academic facilities, employing highly qualified and experienced faculty members, and creating an ambience of conductive quality education. Now I request our resource person, Mr. Jawahar, to take over. Thank you.
Javagar, you can start the session now. Javagar,
Sir, is my screen visible?
no ma, your screen is not visible right now. Can you please share your PDF file? First open your PDF file, then press share.
Sir, is the file visible now?
No, open your PDF file, man. Next, click share and window, then click PDF file. Any problem?
S- I apologize to my viewers right now. You are viewing this live stream, and thank you for the warm welcome. Uh, and I hope everyone viewing the stream is hale and healthy and doing well in their individual part. So I'm here to today. I'm to enlighten the cutting edge new technology of 4D printing technology. Here I am talking about the 4D printing technology. It is it is known as a successor to the very familiar 3D printing technology. In 3D printing technology, we have methods of additive manufacturing, where we add on keep on add a material of particular structure or a particular component from a particular component into a design, where it finally we achieve a 3D project. So how a 3D modeling works generally, it is a object created by taking a de- 2D design as a base, where we model it in a 3D modeling software, and we render it into individual sketches, and then we feed it to the 3D printing printer, where we get a full 3D structured model with three dimensions of length, height, and width, with some volume. So talking about the workflow process of the three of 4D printing technology, it is completely it's not completely different from 3D printing technology, but we have added a few extra phases to the workflow of existing 3D printing working technology. So the pre-process here consists of CAD modeling softwares like CAD, Mayo, and Rhino, which render the 3D models and gi- and it the 3D models are analyzed in a specialized softwares. So the next phase is the process phase. The process phase is the phase where we get a where get into the phase we print a model using the 3D printer. The 3D printer generally uses some polymer material to print the object, because polymer materials are easily melt uh, and upon cooling it gets into a solid form in a room temperature. So coming to the post process of this 3D printing phases, we inculcate powder removal procedure, heating and curling, and polymer and metal infiltration if we require it to be added into the object furthermore. So generally we don't add this polymer or metal infiltration often, because we have completely rendered the 3D object. So why do we add some other materials? So we only add other materials in case if it's very needed for that material. So this is the process workflow of a simple 3D printing technology. Now 3D printing technologies are of different methods. We familiarly use fused deposition modeling, where we use a filament or a metal wire as an input material to an extrusion nozzle. The nozzle is then the nozzle then releases the heated material, and which can be moved horizontally and vertically and um, axially, so the 3D object gets printed. So we also have other methods like printing technologies like selective laser sintering and stereolithography. Stereolithography is nothing but a photopolymerization which used to produce a solid part from a liquid. So these are the common technologies which are in market, but 80 to 90% of the market in 3D printing which use 3D printer technologies go to fused deposition modeling, which is also known as FDM technology, where we simply use a plastic filament to construct the model. So the application of 3D printing are so similar. So they're so simple and similar, like rapid prototyping, 3D printed organs, uh, personal printing in automotive industry and in aerospace industry. So you could ask why I am exaggerating or explaining about 3D printing in a class where we are going to learn about 4D printing technology. The answer is very simple. As the 4D printing technology is the successor of the 3D printing technology, it doesn't have very much difference from the 3D printing technology. So as a base, I would love to explain this the concept of 3D printing technology, and then slowly move into 4D printing technology. So coming to the as I have explained the 3D printing technology, like I have given an overview of it, what technologies are prevailing and which technology the markets use often, and where the 3D printed models are applied. So coming to the 4D printing technology, the aspect of 4D printing technology is developed by Ribbits from MIT, who believed that the fourth dimension in a printing technology, apart from length, breadth, and width, is time. So here in the 4D printing technology, the fourth dimension is said to be as time. You can ask how time can be a dimension. So it's very interesting to explain that. Uh, time can be a dimension in the case of smart materials. I'm talking about this not I'm not talking about very prevailing plastic filaments which are used in 3D printers. I'm talking about smart materials which are used in 4D printing technology, which actuates themselves upon stimuli, usage of stimuli like hot water, temperature, even force and electric voltage. Like if we break an object, like if we break an object, or is the object is broken accidentally, we it reforms itself, so it doesn't get deformed. It reforms itself and regenerates itself to the back where it comes. So according to repeats, the fourth dimension in this printing technology is the time. So I will explain it further. uh, so how it works? Okay, normal 3D printers use a 3D stand, one 2D stand, 1D stand or a 2D surface to make a 3D shape. So it allows the researchers to program different material properties in each of the various particles that is designed by them. So here the objective of the material which is going to be printed is to be not deformed and get regenerated upon any damage. So they are using some they are going to use some smart materials which I am going to explain you in the further slides. The concept is simple, that the smart materials reg- get programmed in such a way that even if it breaks down, it again comes back to the later position. So like this, we construct a 3D object or a 3D object based on a 1D stand or a 2D surface. Okay, you can see in the slide, in between the two rigid 3D structure, we have a small spring-like structures which are developed by smart materials. So the smart material, yeah, this the spring-like structures for is the made up of smart materials. So it is programmed in such a way, so even if it gets deformed into a linear thread, it again pulls back into this particular rendered 3D model. So this is the main concept of the 4D printing technology. We can't use the similar programs like programming softwares or rendering modeling softwares for 4D printing technology as we have used in 3D printing uh, technologies. So we need to step into a new programming technology and a programming software and render and modeling software. So the main difference between the 3D and the 4D printing technology is nothing to do with the fourth dimension, but the big difference is to this printing technology produces the products which are able to adjust themselves according to their surroundings. The 4D printer creates a stand of multiple materials, and that stand becomes whatever we want it to. So we can take a 3D printed two 3D printed objects and fuse it together with the 4D printing smart material. So upon actuation, it actuates the smart material so that it gets reformed and deformed easily, actuating the two 3D printed objects. So this is a 2D plane where a 3D structure is built. So far, comparing to the 3D technology and the 4D printing technologies, we are familiar with this 3D object where we constructed a full object with a volume, area, and some mass. So where we get a full 3D object with length, width, and breadth. So coming to the 4D printed object, this object has a another particular feature which is that makes it unique. So that feature is, if we deform this object into a plane, it is programmed in such a way that it eventually forms back the cube again. So even if we break the cube, if we break a 3D printed model, we can't regenerate, or we have to go for another newly printed 3D object. But here in the case of 4D printing technology, we have the same object which can reform itself upon usage of stimuli, by as the stimuli actuates the smart material to do the necessary need. Okay. The important aspects of 4D printing. We have three main, like, major aspects in 4D printing. Like, we first have the simulation software, next have the multi materials printer, and we have the smart materials. These three aspects form together a cutting edge technology called the 4D printing technology. So, talking about the simulation software, so far in 3D print, so far for 3D printing and other 2D modeling softwares, we have used softwares from Autodesk like SolidWorks and AutoCAD, and other softwares like Dassault systems like CATIA, and even other open source softwares. But here, for especially for dealing with the smart materials and the smart materials printer, the Skylar Tibbets asked the Autodesk to form a new project called Project Cyborg. So this Cyborg software called Cyborg deals with the totally with 4D printing technology and doesn't interfere with 3D printing. So it it, it is the main language where the smart materials and the printer will talk to each other. So the smart for the project of Cyborg, they have programmed it in a such a way that it deals with programming the smart materials, and and coming to the talking about I was talking about the project Cyborg. The project Cyborg deals with the smart materials and acts as a bridge between the smart materials and the multi materials printer, where so the aspect of simulation software in the 4D printing technology is taken care of the software called Cyborg. So for the coming to the aspect of multi-materials printer, so we can't print an object without a printer, so we can't even print an object with a 3D printer. So because it deals with smart materials and the technologies technology is wholly next level, so we have to move to another conventional printer which can deal with the smart materials and give us the required product. So here with the so they have developed a 4D printer, which is nothing but a simple 3D printer, so with some extra features and some extra upgradation. So like printers like StatSys, Rova, SolidView, and GeoMagic are those 4D printers which helps us to achieve the concept of multi-materials printer in 4D printing technology. Coming to the smart materials, I'll also show you some videos and explain this aspect of smart materials which forms the core of this 4D printing technology. Like smart materials are nothing simple but shape memory alloys and self-healing materials. Like it is even to be explained even more simply, if you have come across memory foam beds where we where the hand impressions and body impressions are regenerated back towards normal 2D surface. So that was the concept idea behind developing the smart material, so that if as the memory foam comes back to the base position where it was first, even after impression, smart materials doesn't come back to this base position, to their base position which has been programmed on its own. So they need some actuators. So the actuators act like force, temperature, and even electric voltage can be useful to act as a stimuli to bring back to its base position. So talking about the simulation software, as I told you before, Cyborg 4D simulation software is a software used for to act as a bridge between or the language between smart materials and the 4D printer. So here we have a Cyborg, a designing platform spanning applications from nanoscale to human scale. So we can even program smart materials or even design smart materials in a molecular level or a nanoparticle level. So the Cyborg allows us opens the gates to deal with it. So this software allows for simulated self-assembly and programmable materials, as well as optimization for design constraints and joint foldings. Like I said before, we can use these smart materials in between two rigidly constructed 3D printed materials, so that it acts as a joint. So the joint can be reformed and deformed like a spring on upon actuating and dealing with the stimuli. So the aim is to tightly couple this new cross-disciplinary and scalar design tool with the real-world material transformation of 4D printing. Like the Cyborg 4D simulation software is as the sole objective as to bridge the gap between smart materials and the printer and our product. So the product which is getting printed in with this 4D printing technology should be able to meet our objective as we dreamt of. So coming to the second aspect of multi smart materials printer. So as I said before, 4D printer is nothing but a 3D printer with multi smart materials printing capability. So I have two examples here, like StatSys and Rova 3D. Like StatSys comes with the Conex multi-material technology and Conex 1 printing capability of three materials. So we can fuse three smart materials into single component, so that each materials acts on different stimuli. Like so one material has an actuation stimuli of hot water, one material has an actuating stimuli of electric charge, and one material has an actuating stimuli of force. So we can fuse three smart materials into a single component, which is we are designing. So coming to Rova 3D, Rova 3D is a portable desktop printer which prints 4D printed materials. So we can take it to anywhere we required. So here Rova 3D also provides us to print with five materials. So that we can fuse five different smart materials with different actuators fused together. So okay, compared to upon the sales and the cost of the 3D printed materials, like 3D printers which are used for 3D printing, 3D printers are much more costlier than 4D printers, because 3D printers cannot be easily assembled or easily uh, replace a damaged part in it, so that we can print it throughout the day. So coming to the aspect of 4D printers, as it is portable and comes with a whole new technology, it is far more less costlier than 3D printers. So we can also see the market value growth of this 3D printers and the services and the materials provided by it. So coming about the aspect of smart materials. Smart materials are design materials that have one or more properties that can be significantly changed into controlled fashion by external stimuli, such as stress, temperature, moisture, pH, electronic and magnetic field, as I told you before. Smart materials are nothing but smart metal alloys, self-healing polymers, and dielectric elastomers. Dielectric elastomers are high-end plastic polymers which comes with a smart material which on a acts upon dealing with the stimuli. So the very mic turn gets turned. Okay, now we come to the overview of a 4D object, where we some some smart materials changes physical property upon energy input. Like if you program a material in such a way that it should stand like a chair, and you leave it there. If someone deforms the chair or damages the chair, it is programmed in such a way that the materials come back to the same position where at the spot of the deformation. Like on just applying some heat or giving some electric charge as an actuator to it. So talking about the actuator, we need an energy source so that it deals directly with the smart materials to tell the smart material to do its job. Like if we program a chair using a smart material, and we program it in such a way that it should stay like a chair throughout its entire life. We the smart materials we use will have an actuator which is based on heat, electric charge, or a magnetic field. So if we have developed a product like that and we have sent it to the market in some and somehow and somebody or accidentally it gets damaged, the when the actuating stimuli like heat, magnetic field, or an electric charge is given to the materials where the part is deformed in the chair. So the so the smart materials get the message that it has been deformed, and it should be in the particular position where it should have programmed. So natural energy source or the energy source which deals with the heat, temperature, or the electric charge tells the smart material to go back to its former position. So, and the third overview of this 4D object is the printer, where we can't use a normal 3D printer, but we have to upgrade a normal 3D printer into uh, a 4D printer, which should be able to deliver the product using smart materials. So we have a list of smart materials I have brought here. So the material first, we have three columns like materials input. Like input is nothing but the stimuli, output is nothing but the response upon actuation of the stimuli, and where it is applied. I am not bringing you a whole new concept like I have invented I have enlightening you a new technology where it is prevailing in the market. So they have used a numerous number of smart materials into numerous products upon various applications. So I have brought you some, like a material named polymeric gel acts on a stimuli called pH change. So upon the stimulus of pH change, it responds into swelling or contracting. So this as it is have this characteristics, so the application will be on artificial muscle. So they have applied it in a developing an artificial muscle. So similarly, we can uh, you can see smart material alloys here, which is currently used in BMWs and Mercedes and even Tesla cars, where upon temperature the material changes shape. So if you heat the material, if they heat the smart material, it gives out the output or the response as its deformed shape or reformed shape. So it is applied in motor actuators. So as I said, dielectric elastomers have the input stimuli of voltage, which has a output or the response of strain. So if we give a specific amount of voltage which is prescribed to that smart materials, it induces a strain upon the material so that it reforms or deforms its position where it is being programmed. So it is applied in robotics. Moving upon, how do self-healing material work? So Talking about how a self-healing materials work, eh, I can compare it with our human hand or human cells. Like if we get hurt, this is the part where it deals with uh, the right the right skin colored part is the where it deals with the human cell, and the left skin color part is the part where it deals with smart materials. I have brought it here to show the comparison between how healing pattern works. So, compared to the human normal cell and a smart material which is being programmed. So, in the right part, as we get hurt or we get scratched in some scratched, we bleed. So upon bleeding we lose some cells. So we lose soon, as soon as we lose some cells, and it gets healed eventually upon time. So we heal upon time. So as we heal upon time, why can't a smart material to be can be developed which can be healed by time? So that that is also a main idea which gave rise to this 4D printing technology. So talking about this, how self-healing materials work, here we can see in the right part, we like in a cell, like in a human cell, when we get scratched or when we get damaged or we bleed, the skin there is lost. So the body needs to develop a new skin. So the stages of healing starts like layer formation. Like the whole new layer is formed, like on the full surface where we have scratched or where we have damaged our body or skin. So it it also, thank you, sir, thank you for the comments. I am also seeing viewers pouring in like anything. Thanks guys for viewing this. So upon coming back to the how self-healing materials work, in a human cell we heal in a layer formation, like a whole new layer of cells of the skin is formed over upon our scratches or upon our bleedings. You can see in the left part, left blue circles of where I brought it, of self-healing materials, where it forms it the smart materials starts to regenerate from two individual edges of it. So every linear scratch or a horizontal scratch or a vertical scratch has two edges on it. So to to bring a concept of fast regeneration, we we can see here the material gets regenerated from two edges. So first we have to activate the phase of it. So it like human blood cells, we have brain to tell the skin that you have been scratched and you should be developing a new skin to the blood cells. So we should be also having a similar stimuli like that, to tell the smart materials that it has been damaged and it should be regenerating itself. So that work there is done by the stimuli, like hot water, temperature, heat, or even electric charge. So for example, if a material dealing with the stimuli of electric charge gets damaged, uh, it stays damaged for a while. So upon actuation of the stimuli over it, like giving the electric charge to the material where it gets damaged, the stimuli tells the program smart material to regenerate itself. So it regenerates from two individual edges and forms into a whole new layer upon minimum time. So we first we have the activation phase where we have the stimuli getting the information to the smart materials. Then we have the transportation phase where we have like the smart materials regenerating itself and forming a whole new layer. And finally we have the repair phase. So the repair phase is the final phase where a whole new layer of the regenerated material is formed by the deformed material. So the concept of self-healing materials is not it's not a new one. So it's been an historic idea. Like in ancient medieval period itself, they have used the self-healing materials without naming it the material like they are self-healing materials. Like they just used science. Like the like in ancient constructions like stone bridges in Roman age, despite the fact they have been in for centuries, they stand still upon rain, floods, even even a storm. So the simple concept there is the mortar they use to fuse two bricks together. The mortar, the secret ingredient of the mortar is based on volcanic ash and lime. So volcanic ash and lime made into a mortar, and the mortar pasted in between two bricks, and the bricks formed into a bridge becomes a product which is developed by self-healing material by the Roman age entrepreneurs or Roman age builders. Like they have they have not named the mortar as a self-healing mortar, but they have used the mortar. So the mortar is and upon researchers, the mortar is based on volcanic ash and lime. So what this volcanic ash and lime glue does is the lime dissolves in the rainwater and can seep in through cracks. So when the water it vaporizes, the lime there gets deposited in the crack, and the volcanic ash stays there in between the bricks. So it also strengthens the bricks and the grip between the two bricks. So when whenever the rain pours, they have built it in such a way that they have found a mortar that in such a way that whenever rain actually for cement or a mortar for a construction, rain is the main enemy. Rain and floodwater will be the main enemy. So they have turned the main enemy into their main actuator. So when the main actuator comes to this mortar, the lime in the mortar gets dissolved and seeps into the cracks. And when the water vaporizes on a sunny day, the lime stays there, making the brick rigid, and the volcanic ash gets even more stronger than before, so that the bridge doesn't even collapse even on calamities. So this is the concept, historical concept, the scientists are given a new face and a pace in the current modern trending world. So now, as we have seen the historic applications, we can now see modern applications. Like modern applications, I can proudly boast upon our Indian satellite of Mangalyaan. So in you can Google it and search Google it and see where in the antenna part, where the antenna part which is the receiver of the signals from the earth and the transmitter of the signals is constructed of a material called wolverine cloth, which actuates itself upon any damages from the space debris or like asteroids. I- if a satellite gets damaged like that, a person from Earth can't we can't afford an expedition mission to repair that particular antenna and that particular uh, part of the satellite. So so they have developed in such a the antenna in such a way that the antenna heals itself. So they have programmed it in the 4D printed material, like it heals itself when the asteroid gets hit, so that we have a undisputed transmission to and back to the satellite. So this particular object which I am talking about is a particular part of the material talking about is used in Mangalyaan satellite in our which is sent by ISRO to the Mars. Okay, coming to the application in smartphones, LG smartphone brand as in still in research and in developing a material or small phone that withstand its scratches and even some tiny damages upon developing it with a smart printed material. So this is the another modern day application for you. So we have industrial applications like pipe manufacturing, wall installation of wall manufacturing, etc. So coming upon to the pipe manufacturing, we can develop optic fiber cables with a smart material doesn't get damaged even in rain, even in calamities, even in some larger natural calamities like floods, etc. So that we get a undisputed transmission of signals and communication to and forth. So in a modern, as we are developing ourselves into a modern day, so we can even see more application of this smart materials in industrial manufacturing, healthcare, robotics, even in military, and we have also developed products which are prevailing in the market in automotive industries. So the current state of this technology is that 4D printing is a novel advancement to the printing technology. So upon we as the days goes by, we can't stop innovating till 3D printing technology. So we have to move to the next step, like we have to step ourselves into bigger shoes or bigger goals. So we need 4D printing technology to which deals with the smart materials. So if a 3D printing technology develops a product and it gets broken, we have to replace it with a new product which gives us another whole new cost of developing it. So coming to 4D printed products, even if gets break, it it gets damaged, it it develops itself into its former state. So we eliminate the consumption of whole new product upon the damage of the whole product. So the parts manufactured using this novel technology would employ different types of smart materials. So we won't be depending on a particular smart material which acts on a particular stimuli. So we in future applications we will become coming across many whole new smart materials. So I will end up this slide here. So on the slide, and I will show you some videos which should be supporting my presentation. So and this is how the product gets stimulated, like we have a individual 3D printed objects in between, so that they are programming it in such a way that the smart material gets into that shape of the object. So they have they have dropped a single strand of a linear standard structure into a hot water. So the hot water here acts as an act- actuator, so that the stands in between gives the gives us the shape we required. So they are testing it in a similar programmed structure. So this is how a smart material works. Now we have an octahedron shape. So that upon actuating, upon dropping in the hot water on it, comes to the shape of the football. So they are. It is easy to print. We no need to print a 3D object, like the whole 3D object with the whole weight and height, height and width. So we can simply print a linear object like this, and we program the smart materials to develop the product which we need. So here the whole video depends upon the actuator of the hot water. So hot water here tells the smart materials to do its job. So we have a single linear strand which upon actuating with the hot water comes to a comes to a curved structure. So this is the part where linear constructed strand is dropped into an hot water, like it is the room hot water. Like you can ask why you are saying it's an hot water, and the a human hand is being peeping into the water. So it is like it's an hot water, like it's a warm water. Like it will be in around 30 degree Fahrenheit or something. So it's enough for a stimuli for a smart material to act upon. So even a hair blower can do the job of the stimuli. So it also so so here we have the as we have mentioned about the self-healing cloth. This cloth is printed in such a way that it heals itself upon poking minor holes. Like the rubbing is the actuator here. So if you poke a hole or if it gets damaged, if you rub the surface there, so it comes back to the former position. So we don't use any programming languages here, but we use that we design the product in such a way that it gets the into the former position upon rubbing. So the construction of this object is made in aspect of coding. See the whole vanishing right here. So this is the cutting edge technology developed in Unmanned. So if we have if you have bought a bag with some whole new cost, and if you get if it gets damaged, we have to buy a new bag. So the 4D printed material eliminates that cost. So I have another video of a self-healing plastic, which is programmed in such a way that it heals itself. So they have made a small slide thin plastic, which upon deformation gets healed back to its former state. So the molecules here rebind. So when somebody is slitting the
In the future, we may be able to produce prosthetics and medical implants which can repair themselves inside your body. We can even produce vehicles which potentially could have self-healing properties, which could heal a crack within the vehicle before it can cause any damage to a passenger. Or buildings can be coated with a self-healing layer which will defend it from environmental conditions and damage.
you can very well here see that the plastic is slitted between, it rebinds itself. So it is a smart material which is printed in the 4D printing language. You can see the designing part of that object here. So in future, if it comes in a tempered glass, imagine we don't need a new tempered glass for our phone every time it gets scratched or broken. So this will change the market's strategy.
Thank you so much, Jawahar. Any queries
Thank
from
you,
the
sir.
participant side?
Sir, and the viewers, if you have any queries upon this topic, you can comment in the comment box, so I can view it. Thank you, sir. Thank you, sir.
Thank you. Thank you so much. We will go with vote of thanks.
I would maintain that thanks are the highest form of thought and that gratitude is happiness doubled by wonder. Thank you, sir, for your outstanding discussion. We have now reached the end of this session, and this is the time to extend our gratitude for the successful completion of today's event 4D printing and unmanned aerial vehicles. Gratitude is like a magnet. The more grateful you are, the more you will receive. I deem it my privilege in proposing the vote of thanks. At the outset, I would like to extend my sincere gratitude to the management for providing an opportunity and extending full support to organize such an event. I would like to thank our principal sir, Dr. S. Ramachandran, for being a source of motivation and guiding us to conduct such events. I would like to thank our most eminent speaker, Mr. Jawahar, for spending his time with us and enlightening the stay with his knowledge. Profound thanks to the event organizing committee for playing a pivotal role in organizing and ensuring the smooth conduction of this event. I also thank all participants for accepting our invitation and extending full support. Dear participants, the feedback form will be posted in the chat box. Kindly do fill it. I once again repeat, the feedback form will be posted in the chat box. Kindly do fill it. And once again, I thank you all.